Hello everybody, welcome to the introductory lecture on data structures. In this lecture, we'll be covering Introduction to Programming Language Paradigms, overview of procedure-oriented programming paradigm and object-oriented programming paradigm, their concepts, features, advantages and limitations, comparison between them and their applications. Coming to the Introduction to Programming Language Paradigms, a programming language paradigm is a style of designing and writing programs. Usually, a paradigm is nothing but a model using which we can write the programs based on its specifications. It defines how the problems are solved using programming language. The programming paradigms influence the program structure, that is the way we write the program, and the way we handle the data, that is called as data handling, and the flow between various modules or parts of the program. So different paradigms use are used for different types of applications, and here we focus on procedure oriented programming and object-oriented programming paradigms. Next, overview of procedure-oriented programming paradigm. So procedure-oriented programming paradigm focuses on procedures or functions, or they're also called as methods. So basically, function is nothing but a self-contained block of code which is written to perform a specific task. That means to perform each and every task, we may write a function. Here you can see the picture here. Main program. A main program is further divided into subprogram. Each subprogram is treated as one function. Here you can see function 1, function 2 and function 3. And in turn function 1 is divided into function 4. Function 4 is further divided into function 6 and 7. That means here the main program is divided into three functionalities or three tasks. Function 1 performs one task, function 2 performs another task, function 3 performs another task. And in turn function 1 performs function 4 and function 4 performs function 6 and 7. So they are dependent. So function 2 performs function 4 and 5. Function 3 performs function 5 and in turn function 5 performs function 7 and function 8. So this follows the top-down approach, and here the data is generally shared among the functions, and it is best suited for small to medium-sized programs. So the same example with real-time application. So consider that we, 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 we are developing a project for online shopping application. So the main program is to be written for online shopping application. So to have online shopping, so the application must provide browsing the products, adding the products to the cart, and checkout. So basically, it is divided into sub-functions called as browsing the products, adding the products to the cart, and checking out. And in turn, browsing the products depends on the database, searching the database, and in turn, searching the database depends on filtering different types of items available in the internet and applying the discounts. And next, adding to the cart. So adding to the cart means getting the items from the search database. Search database again means filtering the items and applying the discounts. Next, checkout. Checkout depends on calculating the total amount. The calculating the total amount, of course, depends on the applying discounts and processing the payment. So this is one such an example for procedure oriented programming. Next, features, advantages, and limitations of procedure-oriented programming. Features of procedure-oriented programming are the program is mainly organized around functions or procedures. And of course, it uses top-down approach. The emphasis on step-by-step execution. Data and functions are separate entities, and the functions operate on shared data. Coming to the advantage of procedure-oriented programming, simple and easy to learn, clear program flow and logic, faster execution and efficient memory usage. Debugging is easy for smaller programs, and of course, it is very much suitable for small and medium type applications. Limitations are so low data security. Since the data is shared across the functions, there is no guarantee for the data security, and difficult to manage large and complex problems. Limited code reusability, and the changes in the data affect many functions. Since the data is shared across various functions, there is no security for the data. Next, overview of object-oriented programming paradigm. So object-oriented programming is depending upon classes and objects, mainly on classes and objects. So it combines data and methods into a single unit. It follows bottom-up approach. It supports data hiding and security. And of course, it is best suited for large and complex applications. So you can see the picture here or the right. So data and member functions related to an object. Object 1, its data and its member functions. Object 2, its data and its member functions. Object 3, data and its member functions. You can look at another example, class. The class is person and its members are data members are id, name, age, city, gender. Methods are eat, study, sleep, play. So the data members are the attributes or the features of the objects that are lying under the class, so that we can identify that particular object. And methods are the actions that each object can perform. So you can see the example here. There are two objects with different attribute values or different different values in the characteristics. Name John, age 35, city Delhi, gender male. And coming to the other object, the name is Desi, age 20, city Pune, gender female. The values are different, but they are having the same features with different values. Next, basic concepts of object oriented programming. So the most important concepts of object-oriented programming are the class and object, of course, upon which the other concepts rely. And the other concepts are encapsulation, inheritance, polymorphism, and abstraction. These are the important concepts of object-oriented programming. So class is nothing but a blueprint or template for creating objects, and object is nothing but a real-world instance of a class. Encapsulation, binding the data and methods together. Inheritance, inheriting the properties of an existing class or the other class. Polymorphism, one interface, many implementations. So coming to the real life examples of classes and objects and its allied concepts. Class, the real life example is car. So a class is like a blueprint. It defines the properties and the behavior of a car in general. Coming to the object, specific car. Let me say a Honda City, Tata, Toyota, like that. So you're having several types of cars under the car class. So here an object is a real instance created from the blueprint class. Encapsulation, the real life example is ATM card. You can have the ATM card, you can use the ATM card, but you don't know what's happening actually when you put the ATM card inside. So that is called as encapsulation. The data is hidden and accessed safely. Inheritance, coming to the inheritance, the real life example is a child inheriting the traits from the parents. That is like features, habits, surname, and so on. So these are being inherited from their parents. That means reuse of the features. Polymorphism means existing in many forms. So animals making sound. So that is one example. Making sound means different animals make different sounds, but they make sound. Making sound is one such an example. Making sound action is one such an example. A dog can make one sound, a cat can make another sound, a cow can make another sound, but making sound is common here. Next, so you can see more examples. Animal. So animal is a class, and the objects under the animal class are different types of animals are there based on their features. A giraffe, deer, dog, elephant, lion, and so on. So each animal is one object, but each one is under the class animal. So each one is treated as an animal. Next, another example is car class. So car is a general category under which we are having several types of cars based on their color, their company, their engine power, their fuel type, like that. And coming to another example, more general, A vehicle, usually vehicle is used for commuting purpose. Different types of vehicles are there, and you have a car, you have a bicycle, you have a truck, you have a train, you have a plane, and so on like this. Next, advantages. So the importance of OOPS, its flexibility, its modularity, its reusability, maintainability, and abstraction. So flexibility is it provides binding and extensible. Modularity, separation is there, and of course, yet it provides encapsulation, reusability, inheritance, inheriting the properties from the other classes, where we can have the reusability feature, polymorphism, existing in many forms. You can have one, like for example, you can have one operator which can perform multiple actions. And coming to maintainability, scalable and debugging, and then abstraction, the representation and modeling. So coming to the limitations of object-oriented programming, it requires more memory, and when compared to procedure-oriented programming, it is slower in execution, complex design, and of course, to achieve that, planning is needed, and it is not suitable for very small programs. So comparison between procedure-oriented programming and object-oriented programming. So you can see the program approach followed by object-oriented programming is it divides the programs into segments which are also called as objects. Coming to the procedure-oriented programming, it divides the programs into segments which are called as functions. Program organization, it follows the bottom-up approach, and coming to the procedure-oriented programming, it follows top-down approach. Access modifiers, and of course, object-oriented programming uses access modifiers in order to protect the data, in order to secure the data. Procedure-oriented programming does not use any access modifiers. Coming to the data security, object-oriented programming secures the data by using encapsulation to hide the data. And of course, procedure-oriented programming does not use any data hiding, and there are no additional ways to secure the data. Overloading. So in the object-oriented programming concept, it is possible to overload, and here in the procedure-oriented programming, overloading is not possible. Inheritance. It utilizes inheritance to streamline the code, and of course, procedure-oriented programming does not utilize the concept of inheritance. Data importance. Data is more important than function, and of course, based on this feature itself, it provides the data security. And coming to procedure-oriented programming, function is more important than data. That's why it is called as procedure-oriented programming. In code reusability, code can be easily reused in the object-oriented programming paradigm. And of course, procedure-oriented programming does not allow reusability from one application to the next application. Abstraction. Object-oriented programming uses abstraction on data. Data abstraction is there. In procedure-oriented programming, abstraction is for procedures. Next, coming to various languages under procedure-oriented programming and object-oriented programming paradigm. Under procedure-oriented programming paradigm, C, Pascal, Fortran, COBOL, and under object-oriented programming, C++, Java, Python, C Sharp, Ruby. Applications of procedure-oriented programming and object-oriented programming. Several applications are there, mainly system programming, that is for operating systems, system utilities, and so on, embedded systems, scientific and numerical computations, and small utility programs. Object-oriented programming applications, mainly for web applications, mobile applications, and for enterprise softwares, game development, and real-time systems. Thank you all.